All right, so in the second part of 6.5, the first thing we're going to look at is how to solve a right triangle. When they ask you to solve a triangle, that means to find any sides that are missing and any angles that are missing. So there are 6 things to always know in a triangle. 3 sides, 3 angles. But one of them you always know is a right angle. Okay, so that we already know in every problem we have a 90. So now there's 5 things left to find. Out of those 5 things, to make the problem solvable, I need to give you 2. As long as I tell you 2, you can figure out everything else. I could either give you, in addition to the 90, I could give you one of the other angles and the length of one of the other sides and have you figure everything else out. Or I can just give you both of the sides. It's a little bit different how you solve each case, so we'll go through an example of each. So you're always going to be starting with 3 pieces of information, the 90, and then either the information from case 1 or the information from case 2. Okay, as you are solving the triangles, keep in mind a couple things. All the angles in a triangle have to add up to 180. And we can also use the Pythagorean theorem. The only thing that we don't want to do is we do not want to use information that we calculate to find other information. Why do you think we want to avoid using something that we determined to find something else we don't know?
If you're wrong on the first one,
Right. If the first piece of information is wrong, then you use that. Everything else is going to be wrong. And second, even if the first piece of information is right, it's usually going to be rounded. So if you use something that's rounded to find something else, and then you round again, now you've rounded too many times. That's going to throw your answer off. So in this section, we will never use something we found to find something else. Okay. So how do you do this? Well, first of all, we're only going to use 3 trig functions in this lesson: sine, cosine, and tangent. Secant, cosecant, and cotangent will not be involved with solving right triangles. We might do something with them on the calculator in a little bit, but they are not going to be part of solving triangles. So we're going to pick one of these 3, and then to determine which one you need to use, you're going to draw a triangle, and you're going to look at what side is it that you know. Then you're going to look at what side is it that you need to find, and you're going to name those 2 sides. So let's say that the side you know is opposite. Let's say the side you want to find is hypotenuse. So the 2 sides involved there are opposite and hypotenuse. That's the sine function. If the side that you know is opposite and you're trying to solve for adjacent, opposite and adjacent are the 2 involved. That's the tangent function. Okay? So you're going to look at the side you know and the side you want to know and determine their names. And that'll tell you which trig function to use. Opposite and hypotenuse, adjacent and hypotenuse, opposite over adjacent. Okay, so there's only one choice that would have the 2 sides in it that you want to have. Okay, and then once you choose the trig function that you need, we set up an equation and we solve it. So let's start with this one. This one, they do not give you a diagram and they don't give you any labels. So when you're solving this one, you may use different labels than somebody else. You both would have the same numbers for the answers, but you might call the first answer A. Somebody else might call the first answer B, but you should still get the same answer. Okay. On the test, I am going to give you labels for everything. That also makes it less confusing for me too. Okay. All right. So what do you think the first thing that we should do with that information is?
draw a picture.
Yep, I'm going to draw a picture. I'm going to stick to the naming conventions that I told you yesterday, Greek letters and English letters. Okay. So let's label our sides, A, B, C. And what's the angle across from A called? No, I'm thinking of a Greek letter. Alpha. And what do we always call the angle across from B?
Beta.
Beta. Okay, now I'm going to start to fill in. That's my diagram. Okay. We know that one angle is 37. Doesn't matter which one. I'm going to call alpha 37. If you call beta 37, fine. Your A and B are just going to be switched from mine. It says the hypotenuse has a length of 8. No choice about that one. That's letter C. Right, let's put that off to the side. A, B, C. And alpha, beta. And the third angle we don't need a name for because it's always going to be the 90. Okay, alpha we know is 37. Beta we don't know. A we don't know. B we don't know. So when we're done, we need answers in all three of those boxes. Okay. Anybody see something there that I could figure out first relatively quickly? Mag?
Beta, we just subtract 90 and 37 from 180.
Yeah, so you can add 90 and 37 together and subtract from 180, or you could just subtract 37 from 90, because we know 37 plus, well, alpha plus beta has to be 90. So I would just do that. Okay, so now we know beta is 53. All right, now we're going to find A and B. The order that you find A and B in, it doesn't matter. We're finding everything separate. So you can do technically anything in any order. All right, let's do A first. Okay. I want to find A, so I'm going to circle that. Next, I need to use an angle as my reference. That's like my perspective in the problem. Which angle here should I use as my reference?
Alpha.
Yes, we should use alpha because
It's across from A.
It doesn't have to do with its position, but it does have to do with something else.
Given.
It was given. We know that it's right. Don't use the beta because we could have made a mistake. So we're going to use that angle. We're going to find that side. And what other side do you think we're going to use? The hypotenuse, because that was given. So now let's label each of the sides, the one we know and the one we want to know. And by label, this time I mean their position, opposite, adjacent, and hypotenuse. What is side A?
Opposite.
Right, everything's from the reference of the 37. That's opposite. And the side that's 8?
Adjacent.
Hypotenuse.
Hypotenuse. So you need a trig function that involves opposite and hypotenuse. Which trig function is that?
Sine.
That's sine. So you always set up a trig function just like that. Okay, when you write sine and you put parentheses, that is not multiplication. That's the argument. Just like when you have a log function. Like if you do the log of 2. The parentheses are there to indicate that's the number you are filling into the log formula. Okay? That's what the parentheses are here. They're going to represent the number that's being filled into the sine formula. Okay? All right. So what you put here is always an angle. What's the angle that we're using?
37.
37. Okay, so you always fill in an angle right there. And now, what's opposite over hypotenuse?
A over 8.
A over 8. And now we want to get A by itself by getting rid of dividing by 8. So you're going to times by 8. That cancels, gets A by itself, and that is your answer. Okay, we're going to type that in and round to 3 decimal places. Okay. Before we type it in, what's one thing we should check on the calculator? You should always check this anytime you're going to press one of these 3 buttons. Yep.
If you're in degree or in radians.
Right. In this section, I think all the angles they give you for solving triangles are in degrees. Okay, so I'm in degrees. Bless you. If you're not, you can press mode and you can change into radians. You can change it from radians to degrees. Okay, so type in 8 sine 37, and that gives you an answer of 4.815. Okay, that's A. All right. So now we know 2 out of 3 of the sides of the triangle. What theorem could you technically use at this point?
Pythagorean.
You could use Pythagorean theorem, but what do you think I'm going to say about that?
No, because we don't know if A is correct or not.
Right. We don't know if A is right. It's also rounded, so that's not a good way to find B. So let's find B the same way we found A. Okay, so let's find B. So we're going to set up another trig function, but I need to figure out which one it is. Okay, we haven't labeled B yet. Okay, so now we're going to find B. We're using the same reference angle, and we're still using the given. What is side B? Opposite, adjacent, or hypotenuse? That's adjacent. So now we're trying to find adjacent. We know hypotenuse. What trig function has those two?
Cosine.
That's cosine. Okay, so it's going to be cosine of
37 degrees.
37 degrees. And now fill in the other side. Adjacent over hypotenuse. B divided by 8. Pretty much the same as the last one in terms of the setup. Multiply each side by 8, and the answer is 8 cosine 37. Okay, so it should be about 6.389. Okay, now there's a few things you could check to see if you did it right. One thing that would really give you a good idea is if you do a squared plus b squared, it should equal c squared, or 64. So if a squared plus b squared is 64, then there's a good chance you did it right. If it comes out to like 63.999, that's okay because of rounding. The other thing you can check is the biggest side should always be in the row with the biggest angle. The smallest side should be with the smallest angle. So that's another thing you can check. The third thing you can check is in a triangle, any 2 sides added together have to be bigger than the third. All the ways you can do it. So if you add 4 and 8, that's bigger than the 6. 6 and 8 is bigger than 4. And, well, whichever way I didn't do it yet. So A and B is bigger than C. B and C is bigger than A. A plus C is bigger than B. Okay? Any 2 sides added together are bigger than the third. So there's a couple things you can check to see if you did it right. Okay. Any question on that? All right, let's try one more of that type, and then we'll do the other type. Okay, so alpha is 20, and A is 12.3. First thing I should do. Draw it out. Yep. I always draw my triangle that way. I don't know why, it's just my habit. If you want to draw your triangle a different way, you can. It doesn't matter. That's how I do it. label your sides, label your angles, and that's your generic diagram for every problem. Now fill in what you can. A is 12.3, alpha is 20. Okay, off to the side, I'm going to make a table, and that's just to organize all my answers so I can have everything all in one spot. Okay, I'm not going to write the right angle because we know it's 90. So we have A, we have alpha, no beta, no B, no C. Okay. Again, find anything you want in any order you want. I usually do the angle first. Okay. So what if we do the angle first? What's beta?
70.
Yeah, so they have to add up to 90. Now that you have beta, forget about beta. Okay, don't use it. Okay, we're going to use alpha. So I like to circle the two things that I'm always going to use: alpha and 12.3. Which side do you want to do next, B or C? B, okay. So there's the three pieces of information we're going to use. What position is the 12.3? Opposite. What position is the B? Adjacent. So what trig function has those two? Tangent. Okay, fill in your angle. What's the angle that I'm using for my reference?
20 degrees.
20 degrees, that's like my reference point. And that's equal to opposite over adjacent. Opposite, 12.3, adjacent, B. Okay, this one's a little different. The variable is still on the right side, but it was in the top. Now it's in the bottom. So what could I do on both sides so I don't have a fraction anymore? Yep.
Times it by B.
So times by B. Times by B. The B's are gone. So you have 12.3 on the right. B tan 20 on the left. And now, how would you get B by itself? Divide by what? Yep. Tangent of 20. If you divide each side by tangent 20, that's gone. Now you have B equals, and do the same thing there. 12.3 over tangent of 20. So if you look at that, look at what you started with. Started with that, and look at what you ended with. Does anybody see a shortcut to go right from that box to that box without this step in the middle?
Switch the B and the tangent.
Right. You can always switch what's in the bottom and what's on the other side when you have a setup like that. So if you had this, and you're trying to get the letter by itself, it's easy. All you have to do is switch the x and the 3. That trick always works as long as you have that setup. And that setup comes up a lot in these kinds of problems. All right, well, let's type that in. 12.3 divided by tangent 20. That's 33.794. Don't put a degree symbol on that because that's a side. That is not an angle. Okay, you don't want to start putting degree symbols in the wrong spots. All right. Now, the last thing we have is C. Go back up to your diagram. And this time I'm going to circle what I need in blue. Still going to use what was given. But now I want to find C. What position is C? Hypotenuse. So look at the things that are circled in blue. What trig function would involve opposite and hypotenuse?
Sine.
Sine. Yep. So sine, set it up. Okay, what's your angle you're going to fill in?
20 degrees.
20 degrees. That's we call that our reference angle. That's like our perspective. And then opposite over hypotenuse, 12.3 over C. Okay, same thing happens in this problem that just happened in the one above. How do we get C by itself? Without going through all the steps.
Swap C and sine 20.
Right, just swap C and sine 20. If you don't want to do that or you don't remember that, you can go through it like I showed every time. But that's the result that's always going to happen. Okay, so 12.3 divided by sine 20, we get 35.963. Okay, makes sense that's a little bigger than B because it's the hypotenuse, so it has to be the biggest. And if you add any two sides together, it looks like they are bigger than the third. If you really want to confirm you did it right, check a squared plus b squared and see if it equals c squared. Okay. But don't rely on that to figure it out because we talked about that. Okay, so that's the case where I give you an angle and a side to start the problem. Now we're going to look at the case where you have two sides. But any questions on the first case? Okay, so the second case is a little bit different. So it says the hypotenuse and a leg are 12.7 and 6.1. They don't, well, I mean, they use the word respectively, which means the information in the problem follows each other. Hypotenuse is first, leg is second. Hypotenuse is first, leg is second. But even if they didn't say respectively, if I said I have two sides in a triangle, 12.7 and 6.1, one of them's the hypotenuse, how do you know which one is the hypotenuse? The big one, yeah. Okay, so you need to know that. Okay, so let's draw it out. The 12.7 has to go there. But you can put the 6.1 wherever you want. Okay? You can put it as the height or the base. Okay, but what we should do is we should put labels. Because right now we don't have names for the things we don't know. So I would do A, B, C, alpha, beta. Okay, this time, what is one of the pieces of information that I'm going to use? Definitely.
12.7.
Definitely going to use that. And what else?
6.1.
6.1. And now you choose whether you want to do alpha or beta first. It doesn't matter. Okay, so which angle do we want to try to find first?
Beta.
Beta? Okay. So let's do beta. I cannot do that until I know the positions of the sides. Let's circle beta. So you're doing everything from the perspective of beta for now. What is 6.1 from the reference point of beta?
Opposite.
That is opposite. And what is the 12.7?
Hypotenuse.
Hypotenuse. Which trig function has opposite and hypotenuse in it?
Sine.
Sine. Okay. So fill in your angle. What's our angle this time?
Beta.
Beta equals opposite over hypotenuse. What's different about that?
Opposite and hypotenuse both have numbers.
Right, both the opposite and the hypotenuse have numbers. Where's the letter?
In the sign.
It's in the argument to the sine function. It's kind of like having something like this. The letter is inside a function that is doing something to it. Like in this case, the letter is inside a square root function. If I wanted to get rid of this square root, what would I do on both sides?
Square.
I would square it. That's because squaring and square rooting are like, they're inverses. They cancel each other out. So no amount of adding, subtracting, multiplying, or dividing is going to help you in this problem. You can't do that. You need to use another function to cancel out the function that you don't want there. So we have to do the same thing here. We have the sine function. We have to do something to that that would cancel it out. Okay? So that's what we have. There's different ways you can solve it. We ended up at this step, so I had to change that, which is fine. So that's what we have right now. Does anybody know, and we haven't talked about it yet, the function that cancels out sine? Yeah?
Inverse sine.
Inverse sine, yes. So to cancel out the sine, in this case, we're going to use what's called inverse trig. It's like, I guess you could say, like, if you had a square root of x on each side, technically you could say take the inverse square root of each side. Nobody says it that way. They just say square each side. But that's what you're doing. It's the inverse of square rooting, squaring. Okay, with trig, we do call it inverse. That's the name we use. First of all, the symbol for inverse trig is the abbreviation for the trig function with a -1 up a little bit higher. It's a little confusing to use that notation because you might think that that -1 is an exponent. It is not. That -1, even though it is up higher like an exponent, has nothing to do with being an exponent. It is a special symbol that means inverse sine. That's all it means.
Can you go a little bit quick?
Yep. If you don't want to write it with an exponent of -1, there is another way to write inverse sine, and it's arc sine. They mean exactly the same thing. I usually use the one on the left. I don't use the one on the right as much. But you might see the one on the right in the homework or on a test. Okay, so if you see arc sine, it just means inverse sine. Okay, same with inverse cosine and inverse tangent. So you have to pick the appropriate trig function. If you want to cancel cosine, you use inverse cosine. If you want to cancel tangent, you use inverse tangent. Okay, we are trying to cancel sine, so we're going to use
Inverse sign.
inverse sine. And it's kind of important how you say what you're doing. So we're going to take this equation. I'm going to move it so I have a little more space. And remember, I said no amount of adding, subtracting, multiplying, and dividing is going to help. So you don't want to say any of those words in what you're about to do. What you want to say is take the inverse sine of what's on the left. And I don't have a lot of space, but take the inverse sine of what's on the right. Okay, if I could have fit inverse sine a little bit lower, I would have. But that's the correct word. Just like if you had that. You don't say multiply both sides by the square root. That doesn't make sense. What you say here is take the square root of both sides. Okay, take. That's the verb you want to say. Take the square root, take the inverse sine. inverse sine and regular sine are gone. Now you have the angle by itself. That's what inverse trig does. Inverse trig solves for an angle. That's the only time you use it. Inverse trig is used to find an angle. If you don't need to find an angle, you don't need to use inverse trig. Okay? All right, so let's type that in. Inverse sine of 6.1 divided by 12.7. Remember, that is an angle, so that is degrees. 28.706. All right. And now let's find alpha the same way. I know we haven't done the hypotenuse yet. That's easy. You've done that before, but this might be new. Okay, so now let me circle what we're going to use. 12.7, 6.1, and the alpha. So focus on everything that's in red. We just changed our reference point. That means this name no longer applies because you switched where you're standing in the triangle. Okay, when you switch your angle, you change your perspective, your side names can change. The hypotenuse doesn't. Hypotenuse is always across from the 90. But what is the 6.1 now?
Adjacent.
It's now adjacent because we're solving for alpha, and that is our reference this time. Okay. So set that up. We need a trig function that involves adjacent and hypotenuse.
Cosine?
Cosine. Yep. So cosine, we're going to plug in alpha because that's our angle. And it's 6.1 divided by 12.7. Okay, how am I going to get alpha by itself?
Take the inverse cosine.
Perfect. Those parentheses or brackets or grouping symbol, you can use different kinds of symbols there. That doesn't represent multiplication. Okay? It just represents that we're taking the inverse cosine on both sides. And same thing here. Type in inverse cosine of 6.1 divided by 12.7. And that gives me an angle of 61.294. And if I add that to the one I already got, 61 and 28, that adds up to 89.9 degrees or something. So that's right. Okay, so 61.294. Okay, so that's how you find your angles when I give you two of the sides. Now, the part you've already done before, how can I get the third side if I already know two of them? Yeah, why is Pythagorean theorem okay this time?
Because we have two different sides.
Two givens.
Yeah, we're plugging in given. We're not plugging in anything we found. Okay, so now let's find A. So a squared plus b squared equals c squared. Without even doing it out, what's the first thing we could do to get the a squared by itself?
Subtract 6.1 squared.
Yeah, don't even worry about what it is. Just move it to the other side. Subtract the 6.1 squared. So that's a squared equals 12.7 squared minus 6.1 squared. If I do that out and I round it, I'm just making my answer not accurate. So don't do it out. And how do we get rid of that exponent of 2?
Take the square root.
Take the square root on both sides. We have the square function. We need to do the inverse to cancel that out, just like with trig. Square and square root cancel each other out. And that's what you want to type in. The square root of 12.7 squared minus 6.1 squared, just like that. I haven't done any rounding up to this step. Now I'm going to round. 11.139. Okay, so if you do have to round, you should not be rounding more than once, just at the very end. Okay, and that is the two side keys. Any questions on the two side case? Okay. That's another two side case, I think. I think we're okay. Yeah. Okay. So what does this say? Find the 6 trig values of an angle where 2, 3 is on the terminal side. Okay, let's sketch that. We're going to find the 6 trig functions of an angle where 2, 3, the terminal side goes through the point 2, 3. Okay, so if that's confusing, well, try to draw it to make it less confusing. Mark the point 2, 3. 2, 3. It says the terminal side goes through the point 2, 3. Just like that. Okay, and let's put that like that. So we're looking at this angle in blue. You like blue? Okay. So find the 6 trig functions of that angle right there. Okay. So the easiest way to do that is to basically convert that angle into what shape?
A triangle.
Yeah, make a triangle out of it. The way you can make a triangle, you don't even need to draw your rays as big as I did. I just drew them. But make a triangle from that point straight down. How long is that bottom side?
2.
2. And how about the height? 3. And there's one more side we need. The hypotenuse. What's 2 squared?
4.
And 3 squared.
9.
And what do you get if you do 4 plus 9? There you go. So no, it looks like it's worded a little different. We're still doing exactly the same thing we did yesterday. Okay. What would the sign be? So it's 3 over square root of 13.
So 3 square root 13 over 13.
Okay, so there's your sign. You might think, wait, we already did this before. Yeah, we did. But I'm going to do something different in a second. So we got the cosine. What's the cosine? Yep, 2 square root 13 over 13. Okay, and my tangent? 3 over 2. My cosecant?
Square root of 13 over 3.
Square root of 13 over 3. My secant?
Square root of 13 over 2.
Square root of 13 over 2. And lastly, my cotangent? 2 over 3. Okay, so we did that yesterday. What I want to do now is just look at this first one. I could look at any of them, but the first one is the one I'd like you to use. I want to use this to figure out how big that angle actually is. That's the step we didn't do yesterday. Okay? So let's take this first equation. It doesn't matter if you take the final answer or the version before the final answer. They're equal. So you could just take this first part. Sine theta equals 3 over root 13. Again, I would not leave that as a final answer, but that's not a final answer. It's my work to get to the final answer. I want to solve for theta. What do I have to get rid of on the left if I want theta alone?
Sine.
I need to get rid of sine. What function gets rid of sine? Inverse sine. So take the inverse sine of what's on the left and take the inverse sine of what's on the right. And that will tell you how big the angle is in that picture. And that's what we want to know. Okay, so let's try it. Inverse sine, 3 divided by square root of 13. That angle is 56.3, we're going to round it to 3.1. 56.31 degrees. Okay. Any question on how we got that angle? And again, that is called a reference angle. It's the angle in the picture that I marked. Bless you. And everything was from that reference point or that perspective. Okay. So now, let's do something a little different. Okay. Let's say that I had the point -2, 3. It's kind of like doing this whole problem again, but now that we've already done it, we shouldn't have to do the whole thing again. Let's pretend it said -2, 3. That's right there. If you draw your ray again, it would be like that. And what shape could I make to kind of do what we did before? I could make a triangle again. How does that, let me do them in different colors. How does this triangle in red compare to the triangle that we did in blue?
It's a mirror image.
It's a mirror image of it. Okay? This reference angle is mirrored to right there. That's still your reference angle. How big is that angle right there?
The same.
It's the same. It's
6.31.
56.31. The difference being in quadrant 2 is now the entire angle is from there to there. Okay? When this was our reference angle, that was the entire angle. You draw it from the x-axis to the hypotenuse. Well, if I go from the x-axis to my hypotenuse this time, it's bigger. If that part is 56.31, how would you get that part right there?
Subtract that from 180.
Yes, you would subtract it from 180. We're gonna write that down. When you have a reference angle in quadrant 2, you need to subtract it from 180 because of what I just showed you there. All right. Now let's keep going and let's try it for quadrant 3. Let's say I said that the point -2, -3 was on the terminal side. -2, -3 is right there. Okay. What shape would we make?
A triangle.
Yeah. So draw your angle. Make your triangle. That triangle in black is exactly the same as the red and the blue one. That is your reference angle right there. How much is that angle?
56.31.
56.31. That's not the whole angle. The whole angle is this. So if you knew this part is 56.31, how would you get this entire part?
Add it to 180.
Right. You've gone halfway around plus that much more. So when you are in quadrant 3, you need to take your reference angle and add it to 180. And when you're in quadrant 4, you subtract it from 360. Right? I'm not going to go through that one, but you can draw it out. You can see that yourself. Okay, so we're gonna go through those formulas that you guys just kind of figured out by looking at the diagram. When your coordinate is in the first quadrant, you're done. You don't have to add it or subtract it from anything. The reference angle is the answer for the angle. But if you're in quadrants 2, 3, and 4, the first thing that you have to figure out is what is your reference angle. Okay? The reference angle is always the angle. If I drew the triangle here, okay, it's always the angle that's kind of tucked in right there. It's the angle between the x-axis and the hypotenuse. So that's where it would be in quadrant 1, quadrant 2, 3, and 4. To find that reference angle, you technically could use, where did we do all, I know we did all 6 trig functions somewhere. Well, wherever we did all 6 trig functions, you could, oh, I had all 6, I erased the other 3. You could have used any of the 6 to do this. This is the one I want you to use though, the sine. Right? And because it's a reference angle, it is always a positive number. The only way you would get a negative number for the reference angle is if you plug in a negative number. If you don't plug in a negative, you won't get a negative. Okay? But I'll plug in a negative so you can see what happens. And we'll do it in quadrant 2 or 3. Okay? So to find your reference angle, do the inverse sine, just like we did right here, and always take the absolute value of it. I didn't take the absolute value here because it was already positive. Once you get that number, that is your reference angle. If your coordinate is in quadrant 2, subtract it from 180. If your coordinate is in quadrant 3, add it to 180. If your coordinate is in quadrant 4, subtract it from 360. Okay? And how do you know what quadrant you're in? Well, if your x and y are positive, that's quadrant 1. If your x and y are both negative, that's quadrant 3. Okay, just to make sure we're clear on that. If your x is negative and your y is positive, that's quadrant 2. All right, so we kind of already drew it, but let's try it. What quadrant is 2, -3 in?
2. 4.
Supposedly I can answer.
It's in 2.
2, -3, which quadrant?
2.
Right 2, down 3.
4.
4. Right? It's right 2, down 3. So go right 2, down 3. Put your point. Draw your triangle. Okay, now if you use the negative, it's okay. You went right 2, and technically you went down 3. So if you use the negative, it's okay because we're going to do this at the very end. It's going to end up canceling that negative out. Okay. Here's my reference angle. What trig function did I say we always want to use when they ask us to do this?
Sine.
Right, we always want to set it up with sine. So sine equals, well, I've got the opposite. Opposite is -3. But what am I missing? Hypotenuse. Well, we already found it. This is the same triangle we did in the problem right here, square root of 13. So we set that up. And how would I get rid of sine?
Inverse sine.
Yep. So it's going to end up being the inverse sine of -3 over square root of 13. But remember to take the absolute value. Okay. And you'll see why you need that this time, because you included the -3 as your y value, and that's okay, because you did go down 3. Technically, it is negative. All right, so it's inverse sine of 2 divided by square root of
Sorry, I just
13.
Was it 3 divided by?
It was -3.
Yeah, sorry, I got messed up. Okay. So you get 56, you get the same amount, but notice it comes out negative because you use the negative. But the reference angle is 56.31. So mark that down. Now, the question is to actually find this. What quadrant am I in?
4.
I'm in quadrant 4. In quadrant 4, it says to do 360 minus my reference angle. So 360 minus 56.31. That angle in green is 303.69. That's what they wanted to know. All right, so any question on how to find the reference angle and then apply it to one of the other 3 quadrants? Okay. All right, so the last thing that I'm not worried about, but just in case you don't remember the names of those angles, I'm going to just put that up as the last thing. The angles 0, 90, 180, and 270 are special because they land on an axis, and those are called quadrantal angles. I think we've said that before, but just a reminder. Okay, on the right, that's the homework for tonight. So page 361, 25 to 32, 40 to 42, 45, 49, 53, 57, and 61. Okay, so we'll take a look at that tomorrow, and then we'll start 7.2, and we'll finish 7.2 on